The second lecture about tests. We will talk about test patterns and anti-patterns. A very interesting topic in my opinion, but very poorly covered in books. For example, there is no single book about test anti-patterns. I found just a few books about test patterns, but anti-patterns, nothing. And there are many of them. I found 23 of them. I published a blog post a few years ago when I made a summary of 23 test anti-patterns, and some of them are just, they have different names, but they're still the same patterns. But I'm saying that there are more names for them, but essentially in my opinion, there are 23 of them. We will discuss them. Then we will talk about mocking frameworks, how they work and why they are not really a good solution for testing. Then a little bit about object-oriented programming and tests. And then we will discuss how to make the code more testable. Because that's the whole point of this. That's the very important thing, to make code more testable, and then we finish. Let's start with 23 test anti-patterns. This is the name. These are the names. This is the full list of them, a full list of names of all these patterns. And we're not going to discuss all of them, but we will go through 17 of them, one by one. So the full half of the lecture will be about 17 anti-patterns. All the names are funny. Some names are very funny. Some names are just funny. Let's start with this. Test per method. Imagine you have a class, and in this class, you have methods. For example, the class is book, and in this class you have method title, method author, maybe method rename the book, maybe method reprice the book or sell the book, and so on and so forth. So a bad approach, a bad idea, is to write the unit test which has one scenario, one test scenario per method. So in the class we have, for example, 10 methods, and then you write 10 tests, and each test just tries to call one method from this class. This is the wrong idea, because the class is not a collection of methods. The class is a more complex structure, and your tests have to be designed as scenarios, as scripts, as algorithms, which are using this class, this object, in some scenarios, in some use cases. So don't make your tests like scripts testing one method by method, but instead think of a class in a more interesting scenario. So make up stories for your subject under testing, for the thing you test, stories. And these stories implement as test methods. So many people do the opposite, including myself. I very often make this mistake. So they say, although a one-to-one relationship between tests and production classes is a reasonable starting point, reasonable, so there's a class and you make just one by one, but one-to-one relationship between tests and production methods is almost always a bad idea. Why? Because you lose the concept of an object. Another problem, it's a funny name, a test that has to use unhealthy ways to perform its tests, such as reading private fields using reflection. This again, typical mistake. You look at the class and then you say, okay, I want to, I don't know, I know what's going on in the class. I know what's going on in the method, in somewhere deep inside the class. I have no time, or maybe I have no knowledge how to design a story which will use this class the way that this line, which I know where it stays deep inside, then these lines will be also touched, also tested. So what I do, I use reflection. Do you know what is reflection, right? Reflection is the way is the instrument in Java. It exists in some other languages as well. As reflection is the way to basically open up the class and let you touch any element in the class you want. For example, the class has a private field, private attribute. So the private attribute is inaccessible from the outside. So you cannot just in the test say that I call this method in the class, the method finishes, and then I read the private attribute and I say there has to be number 0 in this private attribute. It's not possible. because the Java will not allow you to touch the private attribute. The code will not compile. With reflection, it's possible. With reflection, you just get you have the special reflection API. Through this API, you get this object. You say, give me access to private attribute. So you crash the Java object. The Java will say, okay, you get the access to the private attribute. You read from the private attribute, and you say, oh, now I know what was there. So you basically violate all the rules. You break the border between you and the class internal things. You completely destroy the encapsulation principle, and you take what's inside. And then you say, and that's why the name of the... Say again? Why reflection even exists?
Reflection was not created for this, but it allows.
Yeah, reflection was not created particular for this. Reflection was created for... You know, reflection is one of the examples of a feature which do not belong to good programming system, good programming languages. Reflection, just like static methods, for example. So, in my opinion, static methods is a bad idea in the first place. So, they should not exist in normal object-oriented programming languages, but they do exist. Why? The best answer is because programmers are not so smart usually. So, most programmers, they just say, my boss tells me to write the unit test. And my boss says I need to write the unit test. How do I do this? This field is private. Can you make this field not private? No, because it's already compiled. I mean, the code is already there. I cannot touch the code. So I need to write a unit test. I don't know how to do it. How about we use reflection? How about you give me this instrument? And they will tell you, no, you need to actually read the book about proper testing. You need to understand how to test it right without reflection. And he says, no, my boss says I need to do it before weekend, so I just do it. And that's it. That's how most programmers behave. They just don't have time, they don't have knowledge, they don't have the intent, the will, they don't have the desire to do it right. So they do it wrong. And majority of programmers are like that. So languages which we have on the market right now are, in most cases, the products of the majority of programmers. So the majority vote, do we need reflection? Yes. 10% says, no, it's the wrong way. Don't do it, reflection, we don't need it. And 90% says, yes. We look at the majority, we make it in Java. Look how Java is being developed right now. Java is developed through new ideas, new things that they submit there, and then they just vote, and they make the Java worse and worse and worse. So the language gets, in my opinion, uglier and uglier and uglier with every second change. Every second version, every next version of Java is killing the language. So eventually it will be as trashy as the C++ right now. So that's what we have. Is the what?
They still add features to C++.
Yes, they continue adding features. They just released the C++ 20. They release standards. Yeah, it's super cool, yeah. They just make new features, so the language gets to the monsters, like...
And actually it has more and more bureaucracy to add.
Yeah, it's more difficult and difficult to add new features.
Some point the future to explode.
Yeah, it's getting uglier and uglier. And that's good for us, because it opens the opportunity for us to make new languages. So these languages, Java, C++, they turn into monsters, and we are here to make our own languages, which are going to be small, neat, nice. People will love them, because people start hating Java and C++. The more powerful they become, the uglier they become. And people, young people especially, they love to do something more fun, more in a hipster way, not in a classic way like C++. It's a monster language. We want something fresh, something new, the language with just a few features, not that monsters and nobody likes. Next one is Happy Path. Happy Path is another anti-pattern. The tests stay on Happy Path. It means that, for example, give an example. For example, expected result, 18 years old. So you provide a number to some function, like how old is the person? 18. Okay, the function returns something in the result. How about you provide -2? Some error situation, some out of boundary number. But most programmers, they make tests the way that the test will pass. The test will be green. And that's an anti-pattern, so you don't do this. So every time you design a test, Don't test what works. It doesn't make any, I mean, it doesn't help a lot. I mean, it's a safety net, of course, you do it, but still, the next step is to make something which provides some unexpected input to your functions, to the objects you test. That will make everything much more interesting, much more effective, and the tests will be much more of a safety net than anything else, than these happy path tests. Another one, Slowpoke unit test that runs incredibly slow. We talked about that at the previous lecture. You see, they have the time to go to the bathroom, grab a smoke, kick the test off before they go home at the end of the day. So your test has to be fast. Slow tests will be killed. And remember, this is the key problem that happens to unit tests. They get killed. Killed means deleted. So the test is in the source code base, and then it doesn't work well, and somebody in the future, maybe you, maybe somebody else, just get into the source code, delete the test, and they're happy. Everybody is happy. Because everybody needs clean build. So they want to see the build green. So I want to run the build, all the tests, they pass, and I'm happy, I release it. I'm not gonna lie, but I definitely have at least 100 open source products on my own, 100, which I maintain personally. I maintain. I created them over the last 10 years, 100 products. Some of them are small libraries, some of them a bit larger, some of them. And sooner or later, once in a while, I need to go back to some of them, which were modified last time, 4 years ago, 5 years ago, and I need to change something there. What do? I open that repository, I pull it to my local computer. I even don't have them locally, they all stay on GitHub. I already deleted them locally, they're not on my laptop. So I clone them I check out from the GitHub. I look at the code and I run the tests. I say build everything before I make any change. Because sometimes people come to me and say, "Can you please improve something? Like in this code, something is broken which you made 4 years ago, and we have users. So how about you fix it?" I think, okay, I'll do it. So I open the code, and first thing I do, Maven. I mean, most of my projects are Java. So I say Maven build, Maven test, Maven install, and it runs through everything. And very often, I can tell you that very often the build is broken. And it's 4 years old. So you can imagine how motivated I am to jump into this code and fix the build. I just look at it and okay, you're broken. Like, was it broken before, 4 years ago? Did it break because something changed over the last 4 years? Because my product depends on something else. I mean, the product depends on libraries, depends on the language. Because 4 years ago it was Java 7. Now it's Java 17 on my computer. No, I'm exaggerating. It was probably Java 8. Now it's Java 14. But still, so the difference is huge. So now my compiler is different. Maybe because of that it breaks. And it happens, maybe. Maybe because my computer is different setup. Maybe the files are gone. I don't know. I don't remember. So of course I try. I go to the unit test. I look at it. And if I don't understand how to fix it in just a few minutes, guess what? I just delete it. Because I have no time, no desire to dig deeper. I have just no intention. I want to close this, to fix the bug, and that's it. And move on. And do what I was doing before. And the problem is that I made these tests wrong 4 years ago. And that's why here, now, I delete them. And of course, when I delete them, I jeopardize the stability of the system. I make the system, the product, weaker when I delete the test. But sometimes I just have no other option. I need to delete them. So all of these anti-patterns, from one way to another, they suggest you not to make tests like I made them 4 years ago. Make tests the way that in 5 years you will be able to open the code. Some of them are broken, and it will happen. They will be broken. So you open them and you say, I understand why it's broken. I change here, this and this, boom, it works again. Cool. But don't delete the test. Don't disable the test. So that's why they say Slowpoke. If you run it in slow, you will just delete it. Everybody will delete it. So don't make tests slow. Another one, unit test that although its validly testing the object under test can span thousands of lines and contain many classes. Well, that's obvious. So if you have a God class, so if you have a huge object, then you will have a huge test. And the huge test is a perfect candidate for deletion. So don't make tests big. Don't make them slow, don't make them big. It's another anti-pattern, they call it giant. Another one, mockery. That's an interesting problem, which we'll discuss in a few minutes later. But basically, it's, do you know what is mocking for unit testing? Yes? I can explain in a few words. So mocking is when you, let's say your test, you have a class, let's call it book, and the book reads, when you ask the book, what is your title? The book goes to the database, reads from the database, and returns the title. That's your class. When you want to write a test for this book, you don't want this book to go to the real database because it's going to be slow, blah, blah, blah. We discussed it before. So what do? You make a mock of the database. It's called a mock or a fake database. They call it fake database or a double database or...
I think they usually distinguish between mocks and fakes.
Yes, they distinguish, but for now it's not important. We'll discuss a little bit later, but I'm just saying there are many names which basically mean the same thing. So it's not a real database. You do something, you create something which is for the tests, which is not a data, which behaves like the database, which looks like the database, which is okay for the book. If you give it to the book, then the book will not understand what happens. The book will still talk to this database and ask, okay, give me the data. And then the data will go to the book will understand it and return back the title. So making this database is called mocking. How you make this mock depends on many factors. Depends on your situation. You can use special frameworks which will help you to create this fake database. You can use other techniques. You can use, sometimes people even start their own database server for the testing. So the book will you will give the normal database to the book, not just a completely fake, like a really fake one, which is in memory, but it's going to be a real database, which will look like real database. So mockery is, sometimes developers, you see, as it says, so sometimes developers can lose themselves in the effort to mock out what isn't being tested. In this case, a unit test contains so many mocks. So basically, the developer sometimes doesn't know what the book will use. So the book says, I need a database. So give me the database. But in the test, we don't know what kind of request will go to the database. Maybe the book will ask for this data in this table. Maybe the book will ask for also some other table, other data. So to prepare as much as possible, we make a long list of things we put into the database, and then one small call to the book. And this is called mockery. This is like a long list of instructions to mock, to prepare something for the real test, and then just a few lines of the test. So when somebody in the future will open this test, they will not understand what's what. They will not know what is mocking, what is the long list of mocking instructions, and what is really the testing instructions. So mockery is also a great candidate for deletion. They will just not understand what's going on, and they will delete their code altogether. Another one is inspector, a unit test that violates encapsulation in an effort to achieve 100% code coverage. This is a very typical temptation. Sometimes people get themselves the target of high code coverage, especially young programmers or people who have not very smart boss. So the boss says, we need 100% coverage. Do it no matter how, but we have to do it because we have to show the number, 100% coverage. But some lines of code cannot be covered or don't need to be covered. For example, that's a very traditional example. Let's say you have a singleton, very simple singleton. In singleton, as you know, there has to be, especially in Java, there has to be a private constructor. A constructor which is marked as private. Why? So that nobody will be able to instantiate the singleton. So that's the idea of the singleton. Singleton may only exist in one instance. In order to achieve that in Java, they make the constructor private. So the constructor can only be called from inside the singleton when we make the only single instance. And then, what about the coverage? The coverage of singleton will never be 100%. Why? Because the private constructor cannot be called from the test. Because it's private, it's empty, of course no lines in the constructor, it's empty, but still there's at least one, but the Java coverage control tool will believe that there is one line. One line in the constructor, total lines in the singleton could be like 10, so 10% is not covered. So you're never gonna achieve 100% coverage. What do you say to your boss? Ah, blah, 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 we have singletons. I don't care, I need 100% coverage. Then we make an inspector. So we make some reflection. So probably we're going to use reflection. So we make some ugly piece of code in order to test this constructor. So if you Google test, unit test for private constructor, you will get to Stack Overflow. And the first question is mine, about 10 years ago. I asked exactly that question. And many people answer that question like, why are you doing this, you idiot? You should not do that. And then some people suggested, no problem, you do it this way. Reflection is your friend. So just Google it and you will see many different opinions about this problem. So inspector is a bad idea. So sometimes you just say coverage 100% is not possible. It's just not going to happen. Don't make your code an inspector. Generous leftovers or wet floor. This is something we also discussed. Wet floor, it means that one unit test creates data that is persistent somewhere, for example, a file, and another test reuses the data for its own purposes. That's really bad idea, but so many people do it. So one test just runs something. How people do it? You're the programmer, you jump into the code, they say create a new unit test, fix the bug, you're full of energy, you would like to create a new unit test, so you say, okay, I need a unit test, so what do I have? So you open the project, you run all the tests, which you run. First step, of course, you run all tests. Then you look at the directory where everything stays, and you see, okay, there are files here, files there, files. So you assume that some files were created during the tests, and you use these files to create your own test. For example, some tests already created a very interesting XML document, which filled with data and everything, but you need exactly this document. So what's the point of making this document again if this document already stays in the temporary folder of the testing environment, of the project? So you just use it, you just assume that it exists there, so you just read it and use it for your own tests. But then somebody else will come in the future, delete the test which was creating this file, and your test breaks as well. Easy. And you don't know how this file was created because it was created by somebody else. So don't make your test depend on something which is left by other tests.
I think that at least sometimes they call test fixtures for that fixtures. So a group
Fixtures.
of tests, yes. A group of tests that
Yeah.
something.
Yeah, fixtures is a good idea. That's good that we mentioned that. Fixtures is something which they say these fixtures are like static resources which stay together with the code, and these resources usually just the text files, or not text, maybe images, maybe some XML files, configuration files. So these files, they are used by the tests and they stay next to the test. So we don't want the test, for example, to, in order to, let's say we write the code and the code, our program is reading, we make a function which can open a file, an image file, the picture, and say what is the size of the picture. Very simple function. So we don't want this. Where do we get the picture? To test this function, we need to have some picture. So we expect this picture to be, we can either create this picture in the unit test, which is difficult, so we need some library for that to create the picture, so that will take many lines of code, or we can just download this picture from internet, some picture, and we put this picture into the directory where our tests stay. And then the test will just start and say, okay, the file is right there, so we can just use this picture and everything is good. So this is called fixture. So the file, like this picture, which stays together with the test, is called fixture. But that's okay. This anti-pattern is not about that. It's about some leftovers which we have after running some tests. Another anti-pattern called local hero. It's a test case that is dependent on something specific to the development environment which was written on. For example, when I write my test, I assume that on my MacBook, on my laptop, I have some library configured the right way, so I can rely on that. So for example, I have some tools installed. For example, I have a tool, let's say, which generates pictures. So I can just call this tool from my unit test, and this tool will generate me a picture of this size, and then I use this picture in the unit test. But you may not have this tool, and the test server may not have this tool, and the continuous integration server will not have this tool. So that's local hero, because it depends on, I mean, I don't know why the name, but it depends on the hidden dependency. That's a better name, hidden dependency. So we depend on something, but it's difficult to understand what. Well, we can understand. We open the text of the test, and when we see what's there, and we see, okay, there's a special tool is being called, and then we're not happy. Next one is called Dodger. Dodger is the unit test which has lots of tests for minor side effects, but never test the core desired behavior. Oh, that I've seen many times. So let's say you have a complex class, a difficult object which does many things, many interesting things, and you don't know how to test them because you don't have time, or you don't have the knowledge, or you just don't want to, but you can test the name of the class, you can test how it returns the title. For example, you have a book, and the book has title, author, rename the book, and a method which is called sell the book. So selling the book means going to the database, doing some complex operations, but you say, okay, I'm not going to test that, it's too difficult for me. I'm going to test how it returns the title, how it returns the author name, and how it renames itself. Easy, you just test. It looks like the coverage is higher, you are happy, but in reality, you didn't really test the core functionality. You only made the coverage higher. And that's not, again, not what you want. So I suggest to start with the most complex functionality when you test it, and then go to minor stuff. Another one, also very popular, Loudmouse. It's a unit test that prints many things to console. Actually, you know, it's a question whether, I even wrote a blog post about this very recently, whether it's necessary to print any information when you test. So when you have your real code, like production code, then in this code you definitely will have some logging. You know what is logging, right? So when you do something, you just print to console and say, I just downloaded some data from the database. It took me 5 milliseconds. Then I just saved some data to the database. It took me another 10 milliseconds. And then I save it to somewhere else, blah, blah, blah. So you print some logs, which is very convenient for production system. And then you write a test. The test will call your production code, and when the test goes, all of these 3 lines will be visible to console, because your production code prints the logging. So when you run the test, you will see these lines in the console. The question is, do we need to print more lines in the test itself? So when you call this somebody, for example, you call this production code and then you return something back, you can just make an assertion and say compare. If it's not comparable, then raise an exception. But before that, you can say print to console, I just got blah, 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 this and that. That took me that amount of time, or something like that. So do we do this or not? That's the question. Some people say yes, but most people believe that it's not a good practice. So a good practice is never print anything from logging, from the console, from the unit test. So all the logs, they should happen in the production code, not in the tests. So the test the logging will happen when you run production code automatically, but you don't add extra logging. You don't log something more from your unit tests. That's a bad practice. So Loudmouse is exactly about this. There's a pattern. What happens is that you print too many diagnostic messages, logging another chatter, even when tests are passing. So maybe when tests fail, then maybe in this case it's reasonable that you print something to the console, because it will make me in the future more comfortable in understanding why there's a failure. But if you print whatever happens, success, no success, but you still print me the messages, then it will only make me confused. So why messages? Why you keep saying so many things in the console? So ideally, when you run your test, they should go quietly, only printing the names of the test. Past, 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 and there's a long, long, long list of them. You have 100 tests, and all of them just go pass, 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 pass. But that's hard to achieve. In most cases, you're going to see many, many log messages going there. Try to stay away from that. Next one, sequencer, another interesting pattern, where the unit tests, they depend on the items on an ordered list. For example, you ask in your test, you ask your class to retrieve the names of the books from the database. The class returns you the list of the books, and they go one book, another book, another book. And in the test, you check whether they go in this right order, or maybe not even whether they go. You assume that they go sequentially in this particular order. But on another computer, there could be another order. For example, there could be another sorting mechanism, another order on like many, many reasons why the ordering of the elements could be different. And the test will break. The test will break for no reasonable cause. So it will be difficult to understand why my test fails, and you will think for many hours, and then you will realize that, on my machine, they go back from the database like ABC. On this continuous integration server, they come back in the CBA, and that's why they fail. So don't make assumptions about the sequence, the order of the elements which are being tested. All right? Another one, enumerator. Test with no name. Yeah, that's funny. Many people do it like this, actually. They name their tests, the test methods, like test 1, test 2, test 3, because they're not creative enough or just lazy, so they have no right names. And how would you actually name the test? Do you know the rule, how the test methods are named? I can give you the rule. So the best rule is to, I don't remember how it's named, because I remember there was a name for that, like this naming convention. But the idea is this: you say, you start with the can, and then you say what can do. So imagine you, in front of your method name, you place the name of the object you're testing. For example, book. And you say, book can read title. So the name of the method will be can read title. So you don't say test. That was, I mean, you shouldn't. I mean, for example, in modern Java, in JUnit 5, you don't need to say test, you just put the annotation test. But in previous versions, it was necessary to name the test method with the test prefix. When it was necessary like this, then imagine that you say test, that, book, and then you say can do this. So anyway, you say test can read title. And actually, in some languages, I remember some tools which were some unit testing instruments, when they read these test methods, they turn the test names into sentences. And in the console, they print you, book can read title, book can write title. So they understand that it was a sentence. So they place spaces between words, they lowercase the words, and it becomes like a normal English sentence. So that's how you should name your methods. Can do something, can read title, can save something to the database, can print name of the user on the screen, and et cetera, et cetera. So first goes the name of the user, name of the object you test, but you don't say the name, so you only start with the can do something. But not test 1, test 2, test 3, of course. Free write, piggyback. Rather than write a unit test case method to test another feature or functionality, a new assertion writes, yeah, it's also a typical mistake. So let's say you have a test method with many things inside. It works, it tests something. You want to test something else because something is broken. So you open this test method, and instead of making another test method, you just say, how about I add one more assertion to it? One more check. There's already 50 lines of code. There's already 5 assertions at the bottom, or maybe somewhere in the middle. So I put another one. Who cares? I mean, and I put it there, I run the test. The test breaks, cool. The test fails, I make the fix, the test is fixed, I'm done. And then the test gets larger and larger and larger, and eventually we'll have a test which tests everything. It runs everything, it tests everything in one large test method. In the end, why it's wrong? Because eventually it will be deleted. Because eventually it will break, nobody will understand why, and they will just kill it. So make your test smaller, and every time you need another test, you make a copy of it, and then refactor a little bit, rewrite a little bit, then make a different test, another one, but make them small, even though they look very similar, even though they do similar things, but it's okay, just copy them, copy. It's good to have many similar tests which look almost the same, it's all right. Code duplication here is not such of a problem. It is a problem, but not as big as a problem in the production code. So this free write, it's called like you take any test that walks nearby and just put the assertion on it. Don't do it. We have 3 more. And do you look at this bar we have on the top? Do you pay attention, yeah? So I made it for good, okay. Excessive setup. Test that requires a lot of work to set up in order to even begin testing. Well, it's close to mockery. Several hundred, you see there's sometimes several hundred lines of code are used to set up the environment for one test with several objects involved. So it's close to mockery. We also, in the mockery, remember we need to mock many things in order to prepare our class for the testing. Here we do some excessive setup of something else. So we make maybe some files, we prepare something. All of this happens usually when the object is not right, is not the right design. When the design of the object is not perfect. Then we need to prepare a lot of things for the object to start testing. So if you see this, if you see that you need to make many things around your code before the code starts working, then it's called excessive setup. 2 more, line hitter. Yeah, that's another anti-pattern, which is another same problem. At first glance, you take a look at the test, you see that it seems to be covering everything because the coverage is 100%, but in reality, they don't really assert anything. So achieving test coverage is possible without actually checking what your code returns. So imagine we have the Fibonacci function. You give the number, Fibonacci number calculates, it returns you the result, and then you check what was the result. Is it the right result? Imagine you do exactly this, but you don't check the result. You give it a number, it runs, it returns you something, and you just ignore it. Do you have code coverage? Yes, you do. I mean, technically. Technically, you have 100%. But do you really test? No, because you don't check the output. This is what is called line hitter. So you hit all the possible lines with all the possible scenarios, but there is no real test because you didn't assert, you didn't check whether the result is actually the result you were looking for. So it is also very popular because people love to see 100% coverage. They love to demonstrate to everybody, look, my code is 100% covered, so look how great we are. We covered everything. When you look closer, you realize that they're just hitting lines. They're not really covering. And the final one, which I decided to show you out of 23, the liar. Evergreen test. The test doesn't validate any behavior and passes in every scenario. Any new bug introduced in the code will never be discovered by this test. It is close to line hitter. You see, they explain. It was probably created after, this is not my text. I took it from all of this text I got from the authors of these anti-patterns. These are not my anti-patterns. I collected them from Stack Overflow, from some books. So, as I told you, there are no single source of this information. Maybe some of you will be interested to write that kind of book. So it was probably created after the implementation was finished, so the author of this test couldn't know whether the test actually tests something. Yeah, sometimes it happens. So that sometimes it's even the software tool can make you this test. So let's say you implement everything, you have the code, and then you say, I need a test. I need the test to exist. So you ask some tool to create the test. The test, of course, will be created so that it passes. So you give the Fibonacci number, it makes you the test, it gives you all the possible numbers here, it checks the results, but it never even tried to It doesn't, you see, a test doesn't validate any behavior it passes in every scenario. Maybe I'm not exactly accurate giving you this example. So maybe when you see the pass in every scenario, that means that no matter what happens with the code there, no matter how you change the code, the test will continue to work. So maybe it's close to the line header. So you call the function, no matter what the function returns. Maybe in this case, even the function throws an exception. The test will also say it's okay, no problem. So the test basically ignores whatever happens there. It just calls the functionality, but doesn't pay attention to result at all. That's another anti-pattern. Mocking frameworks. Mocking, we discussed what mocking is. Mocking is preparing some fake or mock objects before the real object starts working. So these are the parameters, the arguments for the real object. I took this slide from a real code, and this is the slide from a presentation I made a few years ago at a conference. This code is my code. It's not my code, but I saw it in a product which I worked with. You see the amount of mocking and the amount of algorithm which actually does the work. So we need to prepare a lot, and then we do the actual coding. And mocking frameworks, they are used to make this happen. You can click on the link in the QR code. This is the link to the conference talk about this, where I say that mocking frameworks are evil. So using them, so mocking is not a problem. Mocking is necessary. So you need to make these fake or mock objects before you test your algorithm. But mocking frameworks, they make making of these mock objects very difficult to understand.
Well, but it's not that size. But it's not that size because writing mocks by hand may be problematic and buggy.
Writing, well, you need, in the end, you need this mock. You need a fake object. You need not a real database, but a fake database. How do you create it? There are two methods, two ways. The first way is mocking framework. Mocking framework is a special tool, special instrument, which is based on reflection. It uses reflection. So it's a tool where you instruct the tool how my object should look. So you say, my database object should have method read. Also, my database object should have method write. When somebody calls method read, please return this. When somebody calls method read the second time, please return that. And so on and so forth. So it's like very imperative language where you instruct the framework how my object behaves. One by one. Do this. When this happens, do this. When this happens with my object, do this. When somebody calls this, do that. And so on and so forth. And that's why all of this code, this is what this code is about. They just say, probably you don't see it now, but clearly. But they just you see there's no nesting in this code even. It's very imperative, line by line. Like instructions, giving instructions to the framework how my objects, there could be many of them, how they should behave when the real code will start using it. And that's completely ugly, in my opinion. The code which you will see, these mocking lines, the talking to the mocking framework, will make your code ugly and very difficult to understand. A better idea is doubles or fake objects. Again, the link to the presentation. Imagine you have a class book on the left. The class book is Java. The class book expects two parameters, the database and the ID of the book. And then it goes in the method title. When we ask what's the title, it goes to the database, it calls the method fetch, provides the SQL request, and the fetch, let's say it returns the single value from the database. Cool. Now we write the test on the right. When we write the test, we provide not the real database, but we provide a fake database to the method. And this fake database is not made right now by the mocking framework. It was already there, provided by those people who make the real database. So I'm not going to go deeper into the subject. You can understand it. You can read about this yourself. But again, in just a few lines, we need a real database object. And database object exists somewhere. Somebody made it for us. The people who make this object, they have to, together with this object, make a fake database as well. So when you design a library, when you design some objects, together with the real objects, you design fake copies of them. And these fake objects, they have to behave just like normal one, but in a fake way. For example, the real database you design, it will go to Postgres server, make a request, and so on and so forth. The fake database, no matter what we ask it, it will return hello, 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 for example. A very simple one, very stupid one, but returns hello on every request. Will it be okay for this test? Yes, it will be okay for this test. Because we ask for the title. Okay, it's not going to be okay because we expect UML distilled as a return, but it will give us hello. Okay, in this fake database, we can give some parameter to the fake database and say, don't return hello, but return this text which we give to you. That will be okay for this particular test. So it's very small, simple, primitive implementation of the same functionality. Think about this. The next step is object-oriented programming plus tests. One interesting point I will make, and then you think about this. If you look at these traditional tests, again, it's a slide from a conference presentation I made some time ago. Here's the link to the video. So let's imagine this is the test for the book. First, on the first part, the algorithm which makes some manipulations with the book, because book is basically a DTO, it's a data transfer object. You see, we set, and then number 2, we take something from the book, and then number 3, we assert that what we take is equal to what we expect. This is very procedural approach of testing, procedural. When we do manipulations, step by step, algorithm, 1, 1, 1, 1, imperative way, we instruct the object to do something for us. I mean, we inject the data there, and we retrieve the data. It's very imperative. A better way would be to have a rule. That's what I'm suggesting, to have a rule that each test must have only one method call. And this method call is assert. So if you make yourself a rule that each method you write, each test method you write, is a single call to the assert, then you will have to make your objects declarative and immutable and all the good qualities of a good object. So you will not have DTO because it's not possible to make a test with a single method and have a DTO. So you will have to design your code so that it will look much more object-oriented. Again, it's a large subject which you definitely want to study yourself by this link. Because if we go deeper there, then we will have a full lecture about object-oriented programming and this unit testing of the code. So let's talk a little bit about testable code. So how to make, and actually that's a big subject, how to make your code testable. We already had the discussion at the break, during the break about this. It's very important that when you design your code, when you write your code, make your objects, you should think about how to make your objects ready for testing. So don't design them only for yourself. Think about future testers, future people who will automate testing. So every time your code will be ready for testing. And what it means ready for testing, I will explain you. Basically, there are two things. First one is all dependencies that must be injectable. What it means by injectable. Take a look at the left example, take a look at the right example. We saw that code on the previous lecture. So the left example is wrong because the dependency, it depends on the file, and the dependency is not injectable. So nobody will be able to tell this object that, look, don't touch that file, touch another file. It's always connected to one file, always going to touch that single file. And that's wrong. This code is not ready for testing. Maybe it works. I mean, it's a good code. It works. Not good. Okay, scratch that. It's not good code. It's bad code. But it works. It does what it does. It reads the file. Everything seems to be okay. But it's impossible to test it. And that's a problem. The code has to be prepared for testing. The code on the right, on the other hand, does exactly the same. It's semantically equivalent, It does exactly, the same functionality, implement the same functionality, but it's ready for tests because one dependency is injectable. Which dependency is not injectable? Why the code on the right is still bad? Tell me about it.
Why not?
Say louder.
Library function read all lines.
Library function read all lines. That's right. The code on the right still depends on the library files, on the utility class files, and the function read all files. So it still goes to operating to file system. What if I don't want this code during my tests to go to file system? I don't want to make the file at all. I want to inject there a new method of reading the title. That's going to be not possible. I mean, the library is hardwired. The connection from this class is hardwired to the library. They're coupled together. The library, the files dot read all lines, the static method, and my class book. They are connected like this. It's not good. So it's still another dependency, which is also not breakable. And that's when we will need PowerMock or tools like this what you call this, monkey patching. I didn't know this term, but if you say so, I believe this is it. So PowerMock is the mocking framework for Java, which can help you to break any dependency. So if you have code like this on the right, and for example, you don't want this read all files to actually go to the file system, but you want it to do something else, then PowerMock is your friend. So the PowerMock, you say, hey, anytime anybody calls read all lines, you don't do this, you do what I say. And it completely, breaks all the dependence. I mean, it hijacks the Java virtual machine and injects your code in there. It's extremely powerful toolkit which you absolutely should not ever use unless you have very exceptional situations. So PowerMock is an extremely powerful tool for super exceptional situations. But some programmers, they make a mistake and they use PowerMock everywhere. And then their code becomes absolutely unmaintainable. That's just garbage. So PowerMock can kill your code, can kill your tests in just a few days of work. Then you will not be able to test anything. So be careful with PowerMock, even though remember and know that this tool exists. Another recommendation for you to make code testable is for each interface, like I said, for each interface you have to have a fake object. Let's say you have an interface book, so you design this interface, this is your code on the left. On the right, together with the interface, you supply a fake implementation of it. Remember we talked about many lectures ago about object-oriented design, and I told you that it's very good practice for each class have an interface and make sure your class implements the interface every time. So I mean, in most cases, in most situations, in interface and the class. Here I'm saying that for each interface, you not only implement the class, but you also implement the fake class. And then you ship them together, the interface and the fake class. And then when I use your interface, when I use your library, then I have together with your interfaces, I have fake classes. And these fake classes will help me a lot with the testing because I will not need to use mocking frameworks. I will be able to rely on your fake implementations, which is much more compact, much more, code will be much more, short for me. Okay, basically that's it. We're going to finish a little bit earlier this time. So I will tell you about the books. These two books are absolutely great. The second one we mentioned before. The first one is just number one to recommend you to read, which will tell you how to make your code ready for tests. It's called Growing Object-Oriented Software Guided by Tests. So they basically tell you the story of how you make the code and write the code and design your classes by thinking of how they will be tested. So coding and testing, they go along. Coding and testing, they should help each other. And tests are great indicators for you, great helpers for making your code nicer. The second one is also great. It also touches the subject about tests by Michael Feazers, working effectively with legacy code. So these two books, they must be read. Absolutely, no exceptions. You will become much better programmer if you read them both. Where to publish? The same conference I suggested you before, the same international symposium. If you do something for the testing, then go for there and publish there. Call to action. So what to do? I suggest you, if you have tests in your application, and you definitely have to have them, if you use mocking framework and you have to do something for the mocking, so probably you make mocking framework, then I suggest you try to use fake objects. So design them. So along with your real objects, design fake objects and use them instead of mocking framework. Try it out. So what I think are 4 questions which are not answered in the area of test patterns and anti-patterns and so on. First one is how to detect test anti-patterns automatically. That's a big question. So if we look at the tests, imagine we have a huge code base with many, many tests inside. So can we design some tool which will read these tests and will say, hey, you're using anti-patterns here and here and here, like a static analyzer, maybe like a linter, which will be able to look at the code and say where in the code are the troubles, where are the problems, where anti-patterns are used. I don't know such tools. Maybe there are some tools, some static analyzer will give you some hints. For example, for Java, PMD even has the block of the rule set for tests. But this is not as powerful as we discussed. They're not going to catch this complex design anti-patterns. The second question is how to refactor tests automatically. So let's say you have the tests. Can we actually have some tool which will refactor them automatically? Can just go through them and improve them. You know, refactoring, we discussed what it is. Refactoring is the way to improve the code without changing its functionality. So can we make that for the tests? Number 3, how to write fake objects faster. Because writing fake objects could be a time-consuming task, especially when the object is large and you're making a fake copy of it. Then making this functionality can be time-consuming. I can give an example, which I usually give. I many years ago wrote a Java client for GitHub API. So GitHub has an API, and I wanted to use this API from Java, so I found an implementation. I found a library which does it, but the library was not object-oriented. I mean, I didn't like how it was designed, so I said to myself, okay, I need this GitHub API a lot, so I'm going to design my own library. And I designed the library which implements, I guess, about 200 objects, 200 interfaces. Because GitHub is very large API, so GitHub has many things there, like issues, pull requests, stars, forks, users, many, many, many things. So I designed 200 interfaces, and then 200 classes for each interface. So one interface says fork, another says real fork. So fork is an interface, and an implemented fork, like the fork which actually goes to the GitHub, makes HTTP request, retrieves the data and everything. And then I made 200 fakes. 200 fake, but no, sorry, hold on. It was not like that. I didn't make 200 fakes. I made a custom in-memory implementation of GitHub API, of GitHub server. And then my classes worked with this server and providing like a fake implementation of GitHub. So for example, in your code, you want to connect to GitHub and make a pull request there, but you don't want to make real connection to GitHub. So you use my library, my real classes, but you put there a connector which implements everything that GitHub does, but stores all the information in memory in XML format. So you say, for example, make a pull request. It says, okay, I've done it, but it remembers what you asked in XML in memory, like a document, grows. And then you say, create a new user, like give me the user information, make an issue, post a comment to an issue, and everything. So I made like a local server which resembles GitHub, which looks like GitHub. So imagine how much time I spent on that, but the testability got extremely high, because now I have a fake implementation of the entire GitHub server. Of course, it doesn't implement all the features, because GitHub is too big and GitHub is growing, but The library is quite popular. It's got probably 400 stars on GitHub. It's used. I mean, it's one of the top GitHub APIs in Java. And I believe that the most important feature of this API is the fake implementation of GitHub, because no other libraries have that. They don't have it. So when you use them, you have no ability to test anything. You need to use mocking frameworks. You need to build this fake stuff yourself. With my library, you just say, use fake GitHub, and then everything else works just fine. But there's no real GitHub. It's my fake in-memory GitHub. That's just an example to illustrate that fake objects can be, that making fake objects is a time-consuming operation. The final line, how to educate programmers to write better tests. It's a big question, because you see how many anti-patterns we have. Like I said, there are no books about testing anti-patterns, so programmers still don't know how to do it right. The question is, how do we teach them? How do we train them? I don't know. That's a question for you, for the future. How to become better programmers.